Welcome back to Prep Forge. Today's topic comes straight from domain-driven design, and it's one of the most powerful ideas in software architecture, the bounded context. Here's the one-line pitch. A bounded context is an explicit boundary inside which a single model and a single language stay consistent. Cross that boundary, and the same word can mean something completely different. This idea is the key to taming large systems, and it's the foundation for how you split a monolith into microservices. In this video, we'll build it up with one simple example, an online store, and cover ubiquitous language, context mapping, anti-corruption layers, how it relates to microservices, and how to find good boundaries. Let's get started. Let's start with the problem. Imagine a growing company builds one giant model of a customer, shared by every team. Sales thinks the customer is a lead with a pipeline stage. Support thinks a customer is a person with open tickets. Billing thinks a customer is an account with invoices and a payment method. At first, one shared customer class seems efficient, but as teams pile their needs onto it, that class grows dozens of fields, contradictory rules, and constant merge conflicts. A change for billing breaks support. Nobody fully understands it. This is the big ball of mud. The mistake is assuming one model can serve the whole business. Bounded contexts fix this by saying, stop sharing one model. Give each part of the business its own. Concept 1. What a bounded context actually is. A bounded context is an explicit boundary within which a particular domain model applies, and every term has one precise meaning. Inside the boundary, the model is consistent and unambiguous. Outside it, all bets are off. Think of it like this. The word customer inside the sales context and the word customer inside the support context are two different models that happen to share a name. The boundary is what keeps them from bleeding into each other. A bounded context is both a model boundary and a language boundary. Concept 2. The ubiquitous language. Inside each bounded context, the team and the code share one precise vocabulary called the ubiquitous language. Everyone, developers, domain experts, and the code itself, uses the same words to mean the same things. In the shipping context, a shipment, a carrier, and a tracking number are precise concepts. That exact language shows up in the class names, the methods, and the conversations. The rule is one context, one language. When you find yourself saying, well, a customer here means something different, that's a signal you've crossed into another bounded context. Concept 3. Let's make it concrete with an online store. Let's split an online store into 4 bounded contexts. Catalog, which cares about products, descriptions, and categories. Ordering, which cares about carts, orders, and line items. Shipping, which cares about shipments, addresses, and carriers. And billing, which cares about invoices, payments, and taxes. Now here's the crucial insight. A product in catalog is rich with images, reviews, and specs. But a product in ordering is just an ID, a name, and a price. Same word, deliberately different models, each perfect for its own context. You are not duplicating by mistake, you are decoupling on purpose. Concept 4. Context mapping. Contexts don't live in isolation, they have to talk. A context map documents how they relate. Some common relationships. Shared kernel, where two contexts agree to share a small common model. Customer supplier, where an upstream context provides what a downstream one needs. Conformist, where a downstream context just accepts the upstream model as is. And the one interviewers love, the anti-corruption layer, which we'll cover next. The context map is the big picture. It shows every context and the translation between them. Concept 5. The anti-corruption layer. An anti-corruption layer, or a CL, is a translation layer that sits between two contexts, so that one context's model never leaks into the other. Say your shiny new ordering context has to talk to a crusty legacy billing system with a bizarre data format. Instead of letting that legacy model pollute your clean ordering model, you build an anti-corruption layer in between. It translates on the way in and on the way out, so each side keeps its own language. The SCL is how you integrate with a messy external system or a legacy monolith without corrupting your own design. It's one of the most practical patterns you'll ever use. Concept 6. Bounded context versus microservice. Here's the question every interviewer asks. Is a bounded context the same as a microservice? The answer is closely related, but not identical. A bounded context is a logical boundary in the domain. A microservice is a physical deployment unit. The best practice is to align them. Each microservice owns exactly one bounded context with its own database and its own model. That's why bounded contexts are the #1 tool for deciding how to split a system into services. Get the contexts right, and your service boundaries fall out naturally. Split services without finding the contexts first, and you get a distributed big ball of mud, which is worse than the monolith you started with. Concept 7. How to find good boundaries. So how do you find the right boundaries? A few heuristics. First, follow the business. Align contexts with business capabilities and subdomains, like catalog, ordering, or shipping, not with technical layers. Second, follow the language. Wherever a term changes meaning, you've likely found a boundary. Third, follow the teams. By Conway's law, your architecture will mirror your org, so give each context a clear owning team. And watch the size. Too large, and you're back to a big ball of mud. Too small, and you drown in chatty integrations. Good boundaries are where the business naturally splits. Concept 8. What a bounded context looks like in code. In code, a bounded context shows up as a hard module boundary. Each context gets its own package or module, its own model classes, and, ideally, its own database schema. Crucially, there's no sharing of the internal model across the boundary. If ordering needs customer data, it doesn't import the billing customer class. It talks through a well-defined interface, an event, or an anti-corruption layer. The compiler and the module structure enforce the boundary, so a change inside billing physically cannot reach into ordering. The structure is the boundary. Concept 9. When to invest in bounded contexts and when not to. When should you invest in bounded contexts? Use them when the domain is large and complex, when multiple teams work on it, and when you're moving toward microservices. They give you autonomy, clarity, and independent evolution. When are they overkill? For a small, simple application with one team and one straightforward model, one context is plenty. Don't over-engineer. And beware the two failure modes. Boundaries too coarse, and you keep the tangled shared model. Too fine, and every action spans 5 contexts. Said simply, a bounded context is a wall you put up on purpose so that inside it, everyone speaks one language and the model stays clean. Explain the online store. One product in catalog, a different product in ordering, and you've shown you truly get it. And that's the bounded context. End-to-end, an explicit boundary where one model and one ubiquitous language stay consistent. Different contexts, different models, even for the same word, connected through a context map and protected by anti-corruption layers. Align each context with a microservice and a team, and let the business, not the tech, draw the lines. Explain it with the online store and you'll handle any domain-driven design question with confidence. If this helped, subscribe for more. Thanks for watching, and good luck in your interview.